Hello, my dear student. Today I am going to discuss about Edexcel IGCSE Certificate in Physics, Unit 1, Chapter 5, The Turning Effect of Forces. Edexcel IGCSE Physics pages 42 to 48. Content applying to triple science only is shown in the red type on the next slide and is indicated on the subsequent slide by triple only. I am Jahangir Alam. I am a physics teacher. My contact number is 01717979515. Hello, I am Jahangir Alam. I am a physics teacher. Today I am going to discuss about Edexcel IGCSE Certificate in Physics, Unit 1, Chapter 5, The Turning Effect of Forces. Edexcel Specification. After finishing this chapter, we will learn about the relationship between moment, force and perpendicular distance from the pivot. Moment equal to force into perpendicular distance from the pivot. After finishing this chapter, you will learn about center of mass and center of gravity. After finishing this chapter, you can use the principle of moment for a balanced situation. So when any object is in equilibrium or in balanced, then total clockwise moment is equal to the total anti-clockwise moment. And after finishing this chapter, we will learn about stability, characteristics of stable object and different type stability. First, we have to learn about moments. What is moments? Force can cause many things: to move or to stop. When a force causes an object to turn, this turning effect is called moments. Example, a person sitting on a seesaw produces a moment. Moments of a force, also known as turning effect of force. Moment of a force about any pivot is defined as moment equals to force into perpendicular distance from the pivot. So, moment is defined as the product of force and perpendicular distance from the pivot. Moment equal to force F into distance d. Unit of moment is Newton meter. Moment can be either clockwise or anti-clockwise. Force F exerted an anti-clockwise moment through the spanner on the nut. Look at the diagram here. Moment of a force. For example, imagine pushing a door open. You push on the door handle and the door rotates around its hinge. The hinges are pivot here. We exerted a force that caused the door to rotate. The rotation was the result of the moment of your pushing force. We know moment equal to force into perpendicular distance from the pivot. So moment, factor of moment, the moment of a force is bigger if the force is bigger. So moment of a force depends on the amount of force. If the moment of a force is bigger, the moment of a force is bigger if the force is bigger. The moment of a force is bigger if it acts further from the pivot. So moment of a force also depends on the perpendicular distance from the line of action of the force to the pivot. So moment of a force is bigger if it acts further from the pivot. The moment of a force is greatest if it acts at 90 degree to the object it acts on. So the moment will be maximum if it acts perpendicularly or 90 degree angle, with 90 degree angle. Moment of forces. A moment is turning force. So turning force happens when a force applied to something which has a pivot. So a turning force happens when a force is applied to something which has a pivot. The moment of a force with respect to line perpendicular to a plane containing force is the product of force and perpendicular distance from the force to the line or moment axis. So moment equal to force into perpendicular distance. Moments in daily life. We make use of moments of forces in many areas of our daily lives. Look at the example. When we use broom to sweep the floor, one of our hands acts as a pivot and other hand applies a force to produce a moment. Moments in daily life. Example number B. When we use fishing rod, the end of the rod that pushes against our body acts as the pivot, while other hand applies a force to produce moment to lift the catch. Example number C. When we use a wheelbarrow, the axis of the wheel acts as a pivot, and while our hands apply a force to produce a moment to lift the load. Look at the diagram here. Here, there is a spanner here. So we know moment equal to force into perpendicular distance from the pivot. So which one is the perpendicular distance? First, look at the direction of the force. Direction of the force is vertically upward. So perpendicular distance will be 40 centimeter. So remember, to calculate a moment, we need perpendicular distance from the pivot to line of action of the force and or direction. Look at this. Look at the diagram here. We use different type moments in our daily life. When forces are used to open doors, steer or pedal bicycle, or turn a tap, they are using turning effect of force. The effect that a force has is turning an object round depends on the size of the force, the perpendicular or shortest distance between the force line and the pivot. The both of these factors are taken into account when the measuring turning effect of force, moment or turning effect of force. Moment of a force equal to force into perpendicular distance from the pivot or to the line of action of the force. So look at the diagram here. There are three diagrams. So 50 Newton in the first case, 50 Newton acts perpendicularly. So perpendicular distance from the pivot is 0.8 meter, and force is applied here 50 Newton. So moment equals to 50 into 0.8, 40 Newton meter. On the other hand, in the second case, force acts different direction, then perpendicular distance will be 0.6 meter. So moment will be 50 into 0.6, 30 Newton meter. So if force acts parallel direction to the object, then moment will be 0, because force here 50 Newton but perpendicular distance 0. So 50 into 0, 0 Newton meter. So in this from this example, from this diagram, it is observed that moment will be maximum if force acts perpendicularly or at 90 degree. Man-made devices that depend upon the moments of forces: hammers, scissors, spanner, levers, wheelbarrow, steering wheel. Question 1. Calculate the moment exerted with the claw hammer if the person exert a force of 80 Newton and distance d equals 25 centimeter. Look at the diagram first. Here, pivot, perpendicular distance from the pivot to force, direction of the force is distance d. Here it is 25 centimeter. 25 centimeter. We know moment equal to force F into perpendicular distance d. So here force is 80 Newton and perpendicular distance 25 centimeter. So first we have to convert this 25 centimeter into meter divided by 100. So 0.25 meter. So 80 into 0.25 meter, 20 Newton meter clockwise direction. So clockwise direction. Now complete the chart or a diagram here. Look at the diagram. There is a formula triangle here. We know moment equals to force into perpendicular distance. So in first case, 40 Newton is the force and distance, perpendicular distance is 3 meter. So moment will be 40 into 3, so 120 20 Newton meter. In case 2, second case, force 200 Newton and moment 1000 Newton. We have to find out the distance. So distance will be 5 meter because distance equal to moment divided by force. Now in second case, force, we have to find out the force, amount of force. Distance and moment are given. So moment divided by distance equal to force. So 50 Newton. Now case number 4, force and distance are given, but distance here in 20 centimeter. So centimeter unit, we have to convert it into meter divided by 100. So 600 Newton meter. So next, choose appropriate words to fill in the gaps below. There are some option: moments, force, distance, Newton, turning and action. So moment of a force is another name. So moment of a force is another name of turning effect of force. Turning effect of force. Moment of a force is equal to the force multiplied by perpendicular distance between the line of action of the force and the turning point. Turning effect is measured in Newton meter, and moments can be either clockwise and anti-clockwise. Now, a center of gravity. What is center of gravity? The imaginary point where total weight of the object considered to act is known as center of gravity. So it is an imaginary point where total weight of the body considered to act. So the center of gravity of a body is that point at which the weight of the force acts. The center of gravity, a symmetrical body along the axis of symmetry. So look at the diagram. Look at the diagram. Center of gravity of a regular shaped object. So where two diagonals meet at a rectangular object, there is the center of gravity. For us, center of gravity will be at the center of a spherical object. For a triangle, center of gravity also sometimes called center of mass. So sometimes called it is center of mass. So what is center of mass? Center of mass is the imaginary point where total mass of the object considered to act is called center of mass. So center of gravity is also sometimes called center of mass. So center of mass and center of gravity are the same point. But conceptually they are different. If suspended, a body will move to rest with a center of gravity directly below the point of suspension. Look at the diagram here. So if suspended, a body will come to rest with its center of gravity directly below the point of suspension. Finding the center of gravity of a cart or center of gravity. Place the cart in at least two places. Place the cart and suspend the cart from one of these holes. Hang a plumb line from the point of suspension. Using the plumb line as the reference, draw a vertical line on the cart. Repeat for the other holes. The center of gravity is where the lines cross the cart. Then to find the center of gravity, another method: hang the shape or lamina from a pin and let it swing freely. Use a plumb line to draw the vertical line on the shape from the pin downwards. Now repeat this procedure with the shape suspended from a different point to give another line. The center of gravity of the shape is where the two lines meet. Stability. What is stability? Stability refers a body is stable as long as its center of gravity remains vertical above the base. So when center of gravity is vertical above the base, then object will stable. If this is not the case, the body will topple. So if this is not the case, the body will topple. Question: what factors make a modern racing car as stable as possible? So first, wide base, a wide wheelbase. So this is the characteristics of a stable object: a wide base, and low position of the center of gravity. Low position of the center of gravity. Condition of the equilibrium. Conditions for equilibrium. If an object is in equilibrium, the forces on it must balance as well as their turning effect. So the sum of the forces in one direction must equal to the sum of the force in the opposite direction. The principal moment must apply. So when object is in equilibrium, total upward force is equal to the total downward force. And if any object is in equilibrium, then total clockwise moment is equal to the total anti-clockwise moment. Principle of moment. When an object is not turning, that means balanced, then total clockwise moment is equal to the total anti-clockwise moment. Total clockwise moment is equal to the total anti-clockwise moment. Look at the diagram. If the ruler above is balanced, then clockwise moment is equal to the anti-clockwise moment. So total sum of the clockwise moment is equal to the total sum of the anti-clockwise moment. So here, look at the diagram. In the right side of the pivot, there is a weight W2 which acts downwards, so it produces a clockwise moment about the pivot. So clockwise moment will be W2 into D2, and in the left side of the pivot, W1 load force acts downwards. So weight of the load is W1, it acts downwards, so it produces an anti-clockwise moment. So anti-clockwise moment will be W1 into D1. W1 into D1. Question number 1. On a seesaw, Mary weight 600 Newton balances John weight 200 Newton. When she sits 1.5 meter away from the pivot, how far from the pivot is John? Applying the principle of moment, because they are in balance, because the seesaw are in balance, so total clockwise moment is equal to the total anti-clockwise moment. So Mary produces anti-clockwise moment. So Mary's weight into perpendicular distance from the pivot and equal to John's weight into perpendicular distance from the pivot to John's position. So here Mary's weight is 600 Newton and perpendicular distance 1.5. So 600 into 1.5 equal to John's weight 200 Newton, and distance we have to find out the distance here. So 900 equal to 200 into distance. So 900 divided by 200 equal to distance. So John is 4.5 meter from the pivot. Now question number 2. Look at the diagram here. Calculate the weight of the beam. W0 if it is balanced when W1 is 6 Newton. Here W1 is 6 Newton. W1 is 6 Newton and D1, that means perpendicular distance from the pivot to W1 weight, beam weight, known weight is 12 centimeter. And D0, that means perpendicular distance from the weight W0 to pivot D0. So we have to find out the W0. Applying the principle of moment, W1 into D1 equal to W0 into D0. By putting value 6 Newton into 12 centimeter equal to W0 into 36 centimeter, because total clockwise moment equals to total anti-clockwise moment here. So W0 equals to 72 divided by 36. So W0, the weight of the beam is 2 Newton here. Look at the diagram. What will be the total clockwise moment and total anti-clockwise moment? Try to calculate this one. Here In the right side of the pivot, there are two forces act on the right side, F2 and F3. So they produce clockwise moment. So F2 into D2 plus F3 into D3 is the total clockwise moment. So total clockwise moment equal to F2 D2 plus F3 into D3. On the other hand, total anti-clockwise moment F1 into D1. This is a triple only. Look at the diagram here. Complete for a balanced ruler. In the right side of the pivot, there is a load force W2, weight of the load W2 and distance D2. And in the left side of the pivot, there is a load W1 and distance from the pivot is D1. So look at the example number one. Try to solve this one. After application of principle of conservation law of momentum, we can calculate this gap. Try to complete this one. Forces on a beam or a breeze. When the lorry is at the center of the breeze, its weight will be supported equally by the two columns A and B. Look at the diagram. Total downwards force, that means weight of the lorry, but lorry weight 24,000 Newton. So column A and column B experiences equal force. So it will be 12,000 Newton, 12,000 Newton and 12,000 Newton. When the lorry was over column A, all its weight would have been supported by its column. So weight of the lorry 24,000 Newton acts on the column A. So column A experienced a force 24,000 Newton. When the lorry is 3/4 across the breeze, column B will bear 3/4 of its weight. Column A bears the remaining 1/4. Now, what are the column forces when the lorry is 1/3 of way across the breeze? It will be 16,000 in column A and 8,000 Newton in the column B. Why don't crane fall over? Using the principle of moments, when is the crane balanced? We know moment of load force equal to moment of counterweight. So for the crane, find out the force F, that the biceps need to apply the forearm in order to carry a certain weight. When the weight is held static, the system is in equilibrium. So taking moment about the elbow. Look at the diagram here. force F, the perpendicular distance from the pivot. So here taking moments about the elbow point, elbow joint. So elbow joint is the pivot here. So 4 into F, that means force into perpendicular distance from the elbow joint, 4 into F equal to clockwise moment here, perpendicular distance 16 and downwards force, that means weight of the arm is 20 Newton. So 16 into 20, typically above the base of the body, and tractor has a larger wheel base to reduce the possibility of the topping. Okay, thank you for watching. No more today.